The interacting single bed full flow sheet can be used to simulate full cyclic systems of interacting units. The flowsheet makes use of the interacting single bed approach, and this approach is only valid for adsorbent beds that are identical. They have the same adsorbent layers and use the same model assumptions. Only one bed is going to be rigorously modeled. You can incorporate any number of interactions, and the material sent to an interacting bed is actually stored and then reused later in the cycle. We are going to build a two-bed nitrogen pressure swing adsorption process which is operating in a cycle with 4 different stages. In stage 1, bed 1 is in the adsorption stage while bed 2 is regenerating. This stage takes 60 seconds. Stage 2 takes 15 seconds, and bed 1 is depressurizing and bed 2 is repressurizing. In stage 3, bed 2 is in the adsorption stage and bed 1 is regenerating. This stage takes the same amount of time as stage 1. Finally, in stage 4, bed 1 is repressurizing and bed 2 is depressurizing. Each bed is one cycle ahead of the other. Assuming both beds are identical and execute identical stages, instead of sending material to a real interacting bed, we record relevant information on flow, pressure, and composition in a gas interaction unit block. When the bed is receiving material, instead of receiving material from a real bed, the recorded information earlier in the cycle is played back and used. For the full flow sheet, we're going to add to the intermediate flow sheet 2 gas valves, 1 gas product, and 1 gas interaction. Starting from the intermediate flow sheet, we're now going to add the blocks required to have a full cyclic flow sheet. We're going to use the gas interaction unit, and we're going to add 2 more valves, one for the waste product and one for the interaction unit. And we need also to add a product unit for the waste. We now need to reconnect the blocks with the gas material connection stream. Now that we have connected all the blocks, we need to tidy up the flow sheet a little bit. So one of the things we can do is move the original product to the other side, and we can flip it. You can zoom in a particular part of the flow sheet so you can see the ports better. And now we can move these ports around to make it easier. Let's configure the valves for the initial condition. The waste valve is going to be closed, so when it's off, the specification is 0. The feed valve is going to be fully open, so the specification is 1. The valve for the interaction unit must be configured as a non-reversible delay because it's only sending the information one way to the interaction unit, so it can be played back later. And we're going to use a CV specification for it. So that's specification number 2. I'm going to give it a low value of CV. And the product initial specification is going to be a flow specification. The product pressure is going to be very different now. We have a pressure swing adsorption system. Now we're going to specify the gas interaction unit. So this is the unit that's going to store the information on the profiles in the column over a period of time and then play them back when required. We should leave these values as default: delay behavior and first in first out profile to be true. And the first thing in the specify form is to define an initial or an estimated pressure in an initial mole fraction. At time 0, there is no initial profile, there's nothing stored in this interaction unit, so we need to give it an estimate to start from, and then after the first cycle the actual values have been calculated and stored. So for p-stage start we're going to use the value we know. Xfac is a notional bed correction factor. You can find more information about it in the online help. We do not have a reverse interaction, so we don't need to specify a value for the reverse mole fraction. So we're done here. The last step is to estimate the notional volume. So we press the button and this value has been estimated. So we have defined the gas interaction. The other thing we want to do is we want the initial condition for the bed to be full of air in this case, because that's initial point stage 1. That's how we want the system to start simulating. So we're going to change this initial composition in the bed to that of air. We are going to do the same for the tank voids to keep the consistency. And now we can do a flowsheet check and initial to make sure we propagate all the information, then that the flowsheet is checked for compliance.